Good morning. So, as you know by now, I'm out again today. Sorry about that. But we do have to do a little math. So, we started the week learning about counting with the fundamental theorem, or no, the fundamental counting principle, I should say. And today we're going to continue to talk about counting. We're going to work with what we call combinations, which is a way to count a subset of a collection of items where the order doesn't matter. There's a real easy way to calculate these problems using your calculator. There's a function on the calculator that can help us do this math. So it shouldn't be too bad, but I do want to go through and show you some examples. Let's get started because obviously my voice isn't working very well right now. I want to begin by showing you what we mean by a combination. So notice here in this problem, we have a collection of 4 letters, T, V, W, and X. And the combination that we're trying to count is subsets of 2 of these letters taken at a time. So what we mean by that is if I have these 4 letters, I'm going to choose 2 at a time. I might choose something like TV, TW, TX. See how those all have 2 letters? VW, VX, and then WX. Now, because our order doesn't matter, remember I mentioned on the last slide that a combination is a way of counting subsets where the order doesn't matter. Once we count TV, we do not have to count VT. We do not have to count WT, and so on. A combination doesn't worry about the order, just the fact that the 2 letters are in the collection. So I think I've got all the subsets here. Looks like there are 6 of them, and that means that I would be choosing letter B here. Notice like letter A has 2 items here that are the same. VW and WV are the same in a combination, so we would not count both of them. Same thing with WX and XW. Those are not part of a combination. Those are something called a permutation, which we are not working with today. So all of our collections are combinations, and the order doesn't matter. You just want to count the subset and move on. Okay, let me show you how this notation works, and then we'll learn how to use a calculator. So like most things in mathematics, we develop a shorthand notation for indicating that we want to compute a combination. So for example, we use this notation 13C8 to indicate that we have 13 total items and we want to only pick 8. That last problem that we did, we had 4 total items and we wanted to choose 2. So we would call that a 4C2. Now to compute this, there is an actual formula in the textbook. And if you watch that Dr. Berger video, he showed you the formula. But we don't need to worry about the formula because we're going to use our technology here. If you use one of my calculators in class, the way that you compute this 13C8 is first you actually type 13 and then you hit this PRB key right there. And when you hit the PRB key, you'll see a selection up here called NCR. I think NPR comes first and then NCR is second. If you arrow over to the NCR and then hit enter, it will show up on the screen. It will show up on the screen as NCR. And then you type the second number, 8, after it and hit equals, and it'll give you the answer. And when I do that on my calculator, 13C8, I get 1287, which is letter D. So the idea is we don't have to run through the fancy formula because it's been programmed into the calculator. We just have to recognize that we're doing a combination and then type the keys in the right order. So we're going to type the first number, then choose the NCR function using the PRB key, which is right there, and then the 8, and then hit equals. It's that easy. And remember, all of the problems that we're working on today are going to be combinations. Now, just like our other counting problems, we will have some stories. So you're going to have to read some words. But the idea is we should be able to turn each of these scenarios into a combination counting situation. And once we do that, we can use our calculator to get the answer. So in this case, a group of 12 people need to take an elevator to the top floor. They're going to go in groups of 6, and they're trying to figure out who will take the elevator on a second trip. So each trip is going to require 6 people. So I have 12 people total, and I want to pick 6 of them. This is a combination because it doesn't matter what order I choose the people in. All 6 of them are getting on the elevator. So it's a 12C6. I'll use my calculator, so I'll type in 12. I'll hit the PRB key, choose NCR, and then type 6. And when I do that, lo and behold, 924 pops out. And that is choice B here. Right? So I have 12 people. I'm taking 6 of them. So this is a 12C6. Hit the buttons. Boom, I got the answer. It should be that simple. Let me show you another one, and then I am going to show you how to decide whether it's a combination or a permutation, even though we're not calculating any permutations today. We're only calculating combinations. So in this scenario, a team of 15 soccer players needs to choose 2 players to refill the water cooler. It doesn't matter what order I choose the 2 in, they're both refilling the water cooler. So that is a 15C2 situation. And so on my calculator, I type 15, I hit the PRB key, and I do NCR. And then I type 2, and I hit equals, and 105 pops out. What we're saying is there's 105 different subsets of the 15 soccer players that we could choose to get the water. It might be player 1 and player 4, or player 2 and player 8, but when you listed all those options out, there would be 105 of those options, and that is letter A here. So that's a 15C2. Like I said, once you get the hang of using the button, this should go pretty quickly. One last thing to show you, and then this video needs to be done. When you get near the end of your assignment today, you're going to be given a scenario, and you just have to decide if it's a combination or a permutation. In terms of doing this, I know we haven't talked about permutations yet, but basically a permutation is a subset where the order matters. A combination is a subset where the order doesn't matter. So in number 18 over here, a team of 15 lacrosse players needs to choose a captain and a co-captain. Now, because these choices have different roles, like captain is different than co-captain. Because they have different roles, this is a permutation. The order that we select the people matters. If I selected Savannah as captain and Josiah as co-captain, that's different than Josiah being captain and Savannah being co-captain. So because that order that we select them matters, because these choices have different roles, that's called a permutation. So that's a B. Now, in number 19, we've got 35 people in a race, and the top 11 finishers advance. Because all we want to make sure that we finish is in the top 11, it doesn't matter if you're first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, or 11th. As long as you're in the top 11, you advance. So that's a combination because it doesn't matter what order they finish in. All that matters is that they're in the top 11. So that's also a B, but that's a combination instead of a permutation. Okay, that's my sick video, literally. Give this assignment a go, and then I'm hoping that I'll be back tomorrow so I can fill you in on the rest of the stuff and we can get moving. Thanks for your patience, and please complete the assignment there on the ZipGrade student portal. Take care.